So, a quick reminder then of long division. Long division looked like this, and you loved it.
The table.
So, you did long division way back when that looked like that. At some point, oh, you're already getting it. Okay? Now, what I want you guys to think about is what was the process that you were asking yourself? As you went through these things, you'd say, okay,
How many times does this go into this?
correct. So, how many times does 12 go into 46? 3 of them. We put the 3 above the 6 because it's 3 times 12 is 36. And then what'd you do?
Subtract.
Subtract, good. We get 10, drop down the 8, you get 108. Ooh, that's convenient.
9.
Very good. 9 feet is 108 inches. So we do that. We have a 108. I subtract out, I get a 0. I drop down the 4. Does 12 go into 4?
No.
So what do I put here?
0.
Good. 0 times 12 is 0. And I get another 42. I drop that down. And I get 12 goes into 42. How many times? 3 times. 3 times 12 is 36. Hey, look at this! Who would have thought that I would have randomly done that? 5. It worked. Wow. What are the odds?
So the answer is 39,000.
39,035.
All right, now, just for giggles, let's say I wasn't this good at math at guessing something, and let's say this was a 1.
No. Maybe 39,000.
And we'd have 1 left over, right?
35.1.
Ah, we don't do decimals. It's not 0.1
It's 112.
and 1/12. We'd have this and 1/12 would be the remainder, okay? That's how that would work itself out. Now, what we'll do today then is same basic process, but we're going to divide polynomials together. Hey, you guys chose heads. There's a reason why. There's a reason why. Because not so much, I don't know if we might, when we graph some rational functions, I think in about another couple of weeks, you can get rational exponents when you graph them that look like this. Diagonal hyperbolas, if you will. And then there's actually diagonal asymptotes. And you find diagonal asymptotes by polynomial long division. So, let's do this. Let's do a division problem with polynomials. And this is long division. Now, here's what I want you guys to do. The book always writes down division problems the old-fashioned way. What I want you to do is write it out like you would a long division problem. The 2x plus 3 into 2x cubed. Before you write everything out, always make sure that what you're dividing into is in descending order, and you have placeholders for any degrees not represented. Does that make sense? So I have a third degree polynomial, I should have 4 terms. If I don't have 4 terms here, I need to make sure I put like a placeholder in for like 0x or 0x squared or something like that, all right? If you don't do that, you're gonna be wrong like right away. Also, another little top tip, space it out a little bit. Give yourself a little extra space. Okay? It's not a big deal. You'll see why I do that in a second. Okay? You'll see why I do that in a second, just so that there's a little bit more room to write. So here's what you're going to ask yourself these questions. And it's not that this is very difficult, it's very procedural, and it is a little tedious, but it's the same thing each time. So I know you guys are going to be fine with it once you get used to it. And really, the reason that I teach you guys the polynomial long division still is that when you guys go into pre-calc, they just finished this unit where they're graphing and they're putting in the diagonal asymptotes, and this is how you find a diagonal asymptote. You'll see that it's pretty quick to do it. We'll go from there. Here's what you want to do. The difference between long division with numbers and long divisions with polynomials is that you're trying to eliminate, what you're trying to do is eliminate, what's going on? Oh, come on, you want to see it now? Here, you got the, who's got the error message? Write it through. You've got x squared plus 0x minus 1 into your negative x cubed plus 2x squared minus 2x plus 3. The reason I put that placeholder in so you don't forget about it. Okay? So you simplify through, x squared to a negative x cubed becomes negative 1x. You can write negative x or negative 1x. Either one is perfectly fine. Whenever I'm multiplying stuff with the negatives there, if it's just a negative 1, I always put the negative 1. That way I remember that it's negative 1. So I have negative x cubed, 0x squared plus 2x. Subtract, subtract, subtract. So I have 2x squared.
What? It's not 2x.
Not 2x.
Negative 1 times negative 1.
Well, negative 1x multiplied by 0x squared.
That brings it positive x.
To what?
It's, all right, negative here would be negative x cubed. This would be negative x squared, but it doesn't matter because it's still 0. I'm just putting a 0 here, that's all it is. Okay.
So then when you're subtracting it from the 2, it would be like a 1?
No, what's 2 minus 0?
Then why wouldn't you just put a 0?
I'm just putting it as placeholder, that's all.
Shouldn't the last term be just positive x?
Yeah, I don't know why I wrote 2. Thank you.
That's what I wrote.
Yeah, hello. 1 times 1 is 1. Good morning. So then you subtract everything through. For 1 here we have 2x squared. Negative 2 minus 1 is negative 3x. And bring down to 3. And now I just multiply everything by 2. Oh wow, we're going to finish this up quick. 2x squared plus 0x, and then 2 times negative 1 is negative 2. So subtract, we get negative 3x, negative 3 plus 5. That's your remainder. So all you do is up here then, since this was a subtraction sign, you just write minus 3x plus 5 over x squared minus 1. You don't have to write it with the 0x. You can if you want to. And that would be your remainder. It's ugly, but it works. Let's see. So this is 6-5. I'll go back to it. I just want to get this in here real quick. Let's do, so it's 6-5. I don't remember what page this is. Let's just do those 6. That's plenty for a weekend.
Just good idea.
Yeah. It's 356. Let me go back extras. What was that? You had a question? Oh, what do you got?
I thought you wanted to
Do those.
for like 50
Yeah. That's it. Because, quite honestly, we'll probably, I don't know yet if we'll have time to graph rational exponents or rational functions. If we'll have time this year to get to writing out the asymptotes, we might. I don't know. We'll see how it goes. We'll see how close we get. But at least that way you know how to do it. Hey, my kids love that movie.
It's a good one.
It's so. Yeah, the recent one. It's so funny. Like, let's watch Little Rascals again.
Yeah.
Oh, it's been on one. Oh, wait, can you, what do you put in the denominator again?